Hey guys, welcome back to a tutorial on creating creating Tetris within Minecraft. And at this point, what we'll do is we'll go over at a more granular level and a more detailed level the drawing and actually just going to cover the drawing, erasing, and scanning process for each of these blocks, for when we're drawing them, for when we're erasing them, and when we're scanning to see if a new movement or a new rotation is clear for movement. Okay, so you can see I've pulled up this reference sheet here, and these blocks, they have what's called a reference box around them. Okay, and that's going to help us out in keeping things consistent with our drawing and our erasing, and being able to have it so that our game logic doesn't necessarily have to know explicitly what kind of block it's working with. The routines don't have to worry about what kind of block it's working with. It's just going to pass in the current type of block that it is to some routine, and then that new routine is going to go out based on the kind of block, and it's going to go out to the proper locations based on this reference box. So it's a way to it's a way to keep things consistent. Okay, and if you don't quite understand yet, you will soon. So once we start looking into the code, it should all clear up. But first, let's understand. We are going more granular, but it's still pretty complicated, so we kind of have to see at a high level what's going on here. So I've made this little Google drawing, and this little smiley face guy is your cursor drone. So as you can imagine, the little cursor drone that I mentioned in the last tutorial that we're going to use as a tool for tracking the current location, and we're also going to use for drawing the blocks, that's this little guy here. So let's say we have an eye block that's spawned, and first thing we need to do is we want to draw the block. So imagine this little guy, we're going to have to move him to the right, make him place a block, move him up, place a block, move him up, place a block, up and place a block. And then we're going to have to move him back down and back to the left to keep things consistent. Now let's say an update occurs in the game loop. What we're going to do is we're going to actually move this guy out and erase this block with air, so have him place air, and then we're going to move him back down to the beginning at that, in that erase routine, and then we're going to move the cursor drone downwards, thus moving this reference box, so to speak, downwards with this block. And then we're going to do a draw. So we're going to move him to the right place, right place. And as you can imagine, this time everything is one block lower, right? So as you can see, using this sort of reference box system will be helpful, because all we have to do is move this cursor drone around, or erase where the cursor drone is currently, and then move the cursor drone in a particular way, and then redraw. So if we want to move to the left, for example, there, that's how we would end up. And that's how animation works in general. Usually you have the screen gets cleared, and then you perform some transformations. In this case, it's just, for us, it's pretty simple. We're just moving a cursor drone around, and then you redraw. So you erase, perform your transformations or your movements, your changes, and then you redraw. And when you do all that really, really quickly, it gives the illusion that the screen is, or that the particular objects are moving around in the space, when really they're not. They're actually just being erased and redrawn slightly different. Sorry to spoil the magic for you, but so yeah, that's the way that the routine is going to work in both erasing and drawing. Actually, it's going to work the same way if we want to scan as well. So really what we want to do is we want to devise a method that I've already done this, but you guys are going to devise a method that takes into account a block's current rotation and a block's current type, as well as the current cursor drone, so that we can get that reference box system. So it's going to take those three things into account, and it's going to return 4 locations in Minecraft space. Okay, that way, once we have those locations, we can decide whether we want to scan them to see if a particular rotation is clear or a movement is clear. We can choose to erase at those locations, or we can choose to draw at those locations. This way we don't have to recode in a special case for an erase, a draw, or a scanning. It'll make for less code repetition, and it'll also help us test the code easier. So once we have the locations, we know that if we place emerald, for example, at each one of the locations, then we can reuse that same function which we've tested to place air. So we don't even have to test the erase method at that point, because we know that if we do it the same way, then it'll work out. It'd still be a good idea to test it, but it just allows you to have a lot more faith in your program. Okay, so in the next tutorial we'll actually go over the code that gets those locations for each of the different block types and each of the different rotations at a particular location, and really start understanding this code at a more granular, detailed level. Alright, thanks for watching, guys.